Hello and welcome to another Math Monday. We've been talking so much about logarithms lately, so I want to talk about exponents. There's a plane going over. That's really noisy. Bye, plane. Hello and welcome to Math Monday. We've been talking so much about exponents lately. No, we haven't. We've been talking about logarithms. Hello and welcome to another Math Monday. We've been talking lots about logarithms lately, so I want to talk about exponents because logarithms and exponents they're like opposites, right? So in order to know about the one, you have to know about the other. Does that make sense? Of course it doesn't make sense because I haven't started talking about exponents yet. Silly me. Let's talk a little bit more about exponents, exponent rules. Specifically, I'm going to take you through 3 of them today. All right, before we talk about exponents, I want to talk a little bit about the language so you know what I'm talking about when I say certain words. So 4 to the power of 3, that's something that has an exponent. The 4 there, that's actually what we call the base. The 3 is the exponent, and the whole thing altogether is what we call a power. And of course, hopefully you know that 4 to the power of 3 is 4 times 4 times 4. I've gone over that in other videos. It's kind of like grade 8-ish math. I'm not saying that to like put you down or anything. I'm just saying like you can get this. This is something that like 12-year-olds can get, so I know you can as well. Unless you're 12, and then you can get that too. So there you go. Perfect. First thing I'm going to go over is the product rule. Product means multiply. So that happens when I have something like 3 to the power of 2 times 3 to the power of 3. I'm multiplying, so that's a product. Okay, so 3 to the power of 2, that's 3 times 3. 3 to the power of 3 is 3 times 3 times 3, and you multiply those together. So we have 3 to the power of 2 times 3 to the power of 3. When we write it out in what's called repeated multiplication like this, we actually have 3 to the power of 5. Why? Because there's 5 3's being multiplied together. That's 3 to the power of 5. So what happened with those exponents? We had exponent of 2, exponent of 3. How do you take 2 and 3 and get 5? You add them together. So that's what works there for the product rule is you take x to the power of n times x to the power of m and is equal to x to the power of n plus m. I shouldn't have chosen those letters. Okay, wait. Let's just hold on here for a second. Anytime I start putting letters in here, people freak out. They lose it. You guys, it's okay. You're allowed to mix numbers and letters. There's no rule saying that you can't. X is just like, oh, hey, I'm a number, but I'm a number that maybe we don't know yet, or I'm a number that represents any number under the sun that you want me to be. X is just trying to please you guys. Like, don't give X such a bad rap. Poor X is sitting here trying to be anything you want it to be, and you guys just like crap all over it. So just give poor X a break. It's just trying to help you out, okay? Next we have the quotient rule. Quotient means to divide. So if we're dividing 2 things, the answer is the quotient. So say I had 5 to the power of 6 divided by 5 to the power of 4. What's 5 to the power of 6? It's 5 times 5 times 5 times 5 times 5 times 5. I got it 6 times. I had to double check. And then I'm going to divide that by 5 to the power of 4, which is 5 times 5 times 5 times 5. So what we can do here is what we actually end up having is 5 divided by 5 a few times. What 5 divided by 5 is 1. The reason I can just pick and choose those out is because I'm only multiplying the top and the bottom of the fraction, and so I can do that. That's another video for another day if you want to go into the why we can do that. So that's what happens when things cancel out. So many people get confused with the whole canceling out thing. That's what it means. It just means, oh, I can divide those, and when I do, it gets 1, and I don't need to multiply by 1 because that does nothing. So I can cross out 4 of these 5 divided by 5s. What am I left with? I'm left with 5 times 5, which is 5 squared. What happened? You take the 6, you take the 4, you get a 2. Oh, I must have subtracted them. That's what you have to do with the quotient rule. So we have this nice generalization, x being any number, m being any number, n being any number that you want to choose. So x to the power of m divided by x to the power of n is equal to x to the power of m minus n. I did better that time. Thirdly, we have the power rule, and the power is just raising a power to a power. I know that seems really weird and sounds really weird, but you can do that. So say I had 7 squared, and I'm gonna also raise that to the power of 4. What does it mean? It means I need to multiply 7 squared 4 times. So 7 squared times 7 squared times 7 squared times 7 squared. But 7 squared is 7 times 7. So you do 7 times 7 4 times. So you have 7 times 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 7. That's 8 times. So that's 7 to the power of 8. So how do you take 2 and 4 and get 8? Oh, you have to multiply them. So when we have x to the power of n to the power of m, we have x to the power of n times m. Again, I'm using letters just to say these can represent any number you want. I promise I'm not putting the letters there to confuse you. Well, maybe I'm just a little bit, because it's really funny when people get confused when there's letters there. And it's like, literally, it's such a simple thing where it's just, they just represent anything. It's just mathematicians wanting to make a general rule, like, oh, it doesn't just work for these numbers, it works for all numbers, so we're just gonna use letters. And people freak out and say, you can't do math with letters. So, I'm gonna do a little bit of a example here. This is more if you are actually taking math or going to be taking math, you might want to stick around for this example. If you're interested, you can stick around. If not, I'm not gonna take it personally that you don't stick around after that. So for an example, I have x, y squared times x cubed y squared, all divided by x squared y, all raised to the power of 3. There's a lot going on here. So I'm gonna leave that to the power of 3 till the very end. I'm just gonna ignore it. And then I'm gonna take those x's and y's and I'm gonna treat them separately, because we can only use those exponent laws on the same base. So x's and y's, that's the only time we can really use those exponent laws, except for when we're talking about the power law. So on the top of the fraction, we have x, and then we have an x cubed. So I'm actually gonna just bring those together because I'm just multiplying straight across, so I could write it in whatever order I wanted to. So x times x cubed, remember x is x to the power of 1. So if I have 1 plus 3, that's 4. So I get x to the power of 4. Y squared times y squared is y to the power of 4. 2 plus 2 is 4. All right, and then I still divide that by x squared, y, and I'm still raising that to the power of 3. Okay? Still ignoring the power of 3. Let's do the dividing now, because I can do that. But of course, can only divide things with the same base. So I can divide the x's, I can divide the y's. X to the power of 4 divided by x squared, that's x squared. 4 minus 2. That's 2. Y to the power of 4 divided by y, remember that's y to the power of 1. When there's no exponent written, the exponent is 1. So 4 minus 1 is 3. So what I have left in the brackets is x squared times y cubed. And I'm raising that all to the power of 3. So what I need to do is take the x squared, raise it to the power of 3, the y cubed, raise it to the power of 3, do them both separate, okay? What I get is x squared to the power of 3 times y cubed to the power of 3. And then I know from my power rule that I just multiply the exponents. So 2 times 3 is 6, we got x to the power of 6. 3 times 3 is 9, we got y to the power of 9. So that's an example of how you would use all those 3 exponent rules in one example and one question. If you have any other examples for me to go over, please contact me. You can comment below. You can email me, anything like that, if you have specific examples of exponent rule questions that you need me to go over and you don't know how to do. So let me know. I'm happy to do another video on just a bunch of examples if you need that. Otherwise, I hope you guys have such a great week. That's it for me this Monday, but I'm gonna see you soon. Sorry, I had to get that out, you know. Justice for X. I can't believe I just said that. Justice for X! I'm gonna have to live with that now.